Welcome to my projectbazaar.com. Now let's see about classification of Parkinson's disease based on multi-layer perceptrons neural network. Now let's see about the abstract. Here we propose the method to detect the Parkinson's diseases in EMG signal. Initially we pre-process the signal so that we filter the noise from the signal. After filter the noise, we extract the feature in EMG signal. The statistical information of the signal is called the feature, such as energy, momentous, skewness, standard deviation, variation, kurtosis. The mean is the arithmetic average of a set of values. The moment is a quantitative measure of the shape of set of points. The skewness is the measure of asymmetry of the data around the sample mean. The standard deviation shows how much variation or dispersions exist from the average or expected value. The variance is a measure of how far set of numbers is spread out. The kurtosis is a measure of peakness of the probability distribution of a real value random variable. The extracted features will be classified by the backpropagation neural network. From a desired output, the network learns from a many input. Finally, the classifier will predict about the input signal by the land structure. This is the flow of our process. Here we are having the two stages. First one is the training stage and the second one is the testing stage. In training stage, we have to given the whole EMG signals such as normal EMG signal and Parkinson EMG signals also provided. For the provided signal, we are removing the noise by the use of pre-processing technique. Here we are removing the noise by the use of Gaussian filter to the signal. The removed signal will pass to the feature extraction technique. For the feature extraction, here we are using the statistical information such as mean, standard deviation, entropy and kurtosis. Likewise, the features are extracted. The extracted feature will be saved as a feature vector in a single variable. After that, the extracted feature will go to the neural network. PNN is often used classifier. It was derived from a Bayesian network. When an input is present, the first layer computes the distance from the input vector to the training input vectors. This produces a vector where its elements indicate how close the input is to the training input. The second layer sums the contribution for each class of the inputs and produces its net output as a vector of probabilities. Finally, compare transfer functions. The output of the second layer picks the maximum of these probabilities and produces a 1 for the classes and the 0 for the non-targeted classes. After that, the classifier is trained. The input testing signal is given. For the testing signal, initially the noise is removed. After removing the noise, it goes to the feature extraction. Here we are extracting the statistical information of the signal. The extracted feature will go to the trained classifier. Based on the training, it will be identified about the signal whether it is a normal or Parkinson's. Now let's have a demo for process. Here I am having train main.m file. Select this file, right click and run the file. So this is our training guide design. So initially we have to load the normal EMG signal. The normal EMG signal are loaded. For the loaded information, we are extracting the statistical features that are displayed in the first table. After that, we are loading the Parkinson EMG signal. So these are the features of the Parkinson disease features that is displayed in the second table. And then we are going to identifying the feature vector. This feature vector will contain the both normal feature and the Parkinson feature. So totally it will have the 20 features. which combine the both signals. These are the testing process. So initially we have to given the any of the signal. Now I'm selecting one signal as an input. These are the signal is read and displayed here. In pre-processing, we are removing the noise from the input image. From the pre-processed signal, we are identifying the feature. These are the identified features. After that, we are going to the classification. It will classify as a normal signal. After then we are going the analysis part. Here I am identifying the confusion matrix, how much the classifier is performed here. The accuracy is high, better than the existing system. Thank you.